Bonjour à toutes et à tous.
Hello to
Bienvenue à
all.
cette quatrième et
Welcome
dernière
to this
présentation
fourth and last presentation under the theme of the AI, multidisciplinary AI, which optimizes health care. I'm Denis Alahi. I'm a counselor for innovation transfer technology. I'll be the moderator for this conference with my Baba Desel. A few administrative items. As you know, time is precious because the I will be keeping time. The presentation of Mr. François Michaud will be followed by a period of questions. I remind you that you can write your questions down on the bottom of the tab and at all times, just not just at the end of the presentation. And finally, the presentations are recorded, so you will have access to them uh, and see the other presentations if you wish. So the next conference has as a title, What does robotics, telepresence robotics, how can it contribute to numeric health, digital health? I wish to introduce François Michaud, professor at the Department Electrical Engineering and of Computer Engineering Department at Université de Sherbrooke, and director of the Robotics Engineering Department. Mr. Michaud, the floor is yours. Thank you very much. It's a pleasure, not necessarily with the title that we will speak of robotics, just to situate yourself, the context in which the presentation will be done. You have to understand from where my interest stems for numeric health, and it comes from, incidentally, from robotics. My objective as a researcher is to develop intelligent robots, robots which will be used to help us on a daily basis, and that requires to get the robots out of the cages that we have in plants and to bring robotics to interact in a natural way with persons. Uh, to be able to do this, you have to give them intelligence, and it has been my research interest have been oriented directly as to how artificial intelligence could apply to robotics to bring them to be intelligent machines. And we wish, beyond the challenge of manufacturing an intelligent robot, we wish this to be used in the daily life to resolve problems, improve our quality of life. And for this, well, a good part of my research has been oriented in working with the clinicians in the healthcare sector, and that is done through initiatives such as Age Well, which is a network of excellence centers on Canada on technologies to Age Well, and on the bottom right logo, which is a strategic IGWI, which is a strategic bottom left, a strategic group which brings specialists in robotics and technology and computer science to work with researchers, clinicians, or researchers more oriented towards the humanities and social sciences, which want to bring technological solutions which are hidden in our labs to resolve issues which are not solvable or resolved with technologies which are commercially available. So to bridge this is one of the missions that we've given ourselves with the 3IT Institute, the Interdisciplinary Innovation Institute. It is the backdrop that you have of behind the explanations that we'll give in the next moments. So what is telepresence robotics? If I show you different examples here, we are talking of telepresence when we have the control of a robotic platform at a distance remotely. And that is examples of AGO platforms. It is the equivalent of doing video conference but mobile. So we see the face of the speaker, which is placed on a stand, which is motorized, which is capable of receiving commands to move forward, back, turn around, and for the remote operator that you see on the screen, and we see what the robot sees with cameras, we hear what the robot can hear, and same thing, the person which is speaking remotely, we will hear through the robot, we will see the visual as well. So it's interesting to be able to interact, to move around in a place and in a distant environment without having to physically travel there. The interesting applications for a clinician, a physician, a helper to come and see what's coming on in the loved one's environment, come and interact in a more natural way while being remote. The idea is that while the operator is doing this, he's in charge of controlling the robot. So to navigate in an independent remote manner with a remote control or the keyboard commands, and must concentrate on the interaction that this person, remote person, has with the person besides the robot. So the idea, the objective is to bring intelligent, which is in the head of the operator, bring this intelligence to the platforms so that the operator can concentrate more on what's going on with the subject. And before I move on to the next slide, we see that they are platforms that can move around. There is only one right now, which is shows the possibility to have some sort of an actuator or manipulator. So it's beginning. Talking in the price interval between 20 and 20,000 dollars. So we, as a research lab at the Sherbrooke University Intralab, we are trying to give independent capacities to these platforms. So here is an example of one of the commercial platforms that we've increased the number of sensors to give it this independence. So a depth camera, the equivalent of a Kinect camera that you probably know for the Xbox One, which is a gaming platform, a microphone matrix to give the equivalent of a near which can localize sounds and to differentiate them, and a computer with batteries for the processing capacity. Here's an example we're showing with an operator, which we would see his face. As I said, the equivalent of a visual conference. The operator has on top of that an interface which allows to actuate the modes of interaction, automatic interaction modes. For example, we can imagine a robot which interacts with a person, but if we're follow up on the face, the operator doesn't have to concentrate to position the robot in front of the person if that person is moving. So that's already an interesting function. Same thing if there's several speakers. Uh, we would have to move around, but with the microphone matrix, we are capable of localizing sound and to direct the robot in the direction where there are sounds. A third functionality, the reading of vital signs, interesting as a need for assistance to care because now we are ensuring that the person which is taking its vital signs is doing it in the correct manner. We can validate the measure. In this case, it is with a pulse oximeter. We can take weight measures. We and read the vital signs and to ensure that the data are correct before placing them in the e-file of the patient. For navigation, the robot with his depth camera, the camera, is capable of taking images of the environment to create a map of this environment, which will be used afterwards to localize the robot and receive commands as the type. You can go to this place. Your charging station is in this place, and it will be able to go to this place in an independent manner, which is very practical because a clinician or a once the interaction is done, will not be able to bring back to this charging station. You have to be able to get the robot back to the right spot. So this is an example of work on intelligence of the platform that we are developing in Sherbrooke. We have the same functionalities which are transposed to on robots. I'm sorry, I would have wanted to be able to move along the video, but I think I'm not able to do so. Oh, I'm sorry. We'll just play it again. I'll go this way. We can transpose the same functionalities on platforms, mobile platforms, such as for security. We have in this manner, I'm sorry, it's chopped up here, but the capacity, I'll go directly to where the spot where I need to go. We are capable with a robot which has the same navigation capacities of a the telepresence platform to generate patrols. So a robot can receive commands to go from one place and do a certain path and take images on what's going on, record, for example, if there are intrusions, if there are people that are appearing in places where they should not be. Also, to be able to see, speak, interact with persons through the platform. So robots security robots such as these, when we show this to elder care homes, they become interesting solutions because they are capable. They could be used to measure or monitor hallways to avoid nocturnal escapes. So it's the same functionality that I was speaking of in another platform, the SAM platform, but applied to a slightly different application, and it must have the capacity to recharge. So if I change slides, if I can change slides, maybe I'll try to relaunch it just in case it works. Yes. On the mapping part, when we showed these capacities to colleagues in occupational therapy, they saw the creation of a 3D map, and we said, oh, this could be used in the work we do for the assessment of a patient. If someone is in for a surgery for knee or hip surgery and going back home with a walker or specific assistive devices, one of the work to be done by the occupational therapist is to go home and to measure the different key areas in a home to ensure that we have the right recommendations of walkers, of wheelchairs to put appropriate guards. And that's an operation which is tedious. It can take an hour, 45 minutes, take the height, for example, the tub um, of the toilet height, the switches, the door widths, the door thresholds. So it is work that they do manually with a standard tape measure. And when they go back in the clinic, they must use this data to be able to inform other healthcare professionals which will do recommendations from this. So it is not very visual. Their request was to be able to transport this and take this mapping on a mobile device. Right now, there are phones, tablets, such as the iPad Pro, the iPhone Pro 13 and 12, which are equipped with depth cameras, and we can just paint numerically, we could say the room, to obtain a 3D model, which can also then be used to generate measures automatically, or by clicking and pointing inside of this 3D model with, on top, measures to have a visual of what is found in a typical room in that person's environment. So it is very practical. It avoids returning if needed, and it gives more information than if we would have to make measures manually. It is an example of measures generated automatically. The accuracy is about of half a centimeters, depending on the surfaces, and we are able to take the measures that we need. The same type of application can be used to map a complete household still by scanning with a portable device. The idea, which is interesting, is that it can be a resident which does this work. So the healthcare professional doesn't necessarily have to uh, visit or could visit afterwards to have more specific data, but at least would already have a visual or an initial scoping which is done, which is archived well. And there's other applications which can be used specifically for persons which want to who need specific environments and want to move. We could have banks of information of this type on available housing depending on wheelchair users or walker users, and they could use these 3D models to have the specific measures on how they will be able to operate in that type of environment. I'll remind you that this and such hasn't been developed for this application. It's been developed to give intelligence to robots so that they can navigate independently. But there's an obvious transfer which is done, knowing applications and people in occupational therapy that have that need. Another interesting element is to be able to do this, telepresence robots, we need an environment, a video conference environment. And it would be neat to work with commercial platforms, transmit audio and video, but it's not enough. We have to be also able to transfer data today, transfer commands towards the robot, and to receive information from the robot sensors. So we developed OpenTerra, which is a platform free of rights, so which allows to install servers in secure places, hospitals, persons' houses. Don't need to transmit data on Teams, Zoom, by servers outside of the country, and which allow clinician participants and patients to have a visual platform dedicated to application of telehealth applications. We give an example here with the clinicians, which has a specific interface to manage his sessions and can take, for example, uh, the healthcare professional can take a picture and measure the angle with a tool that has been specifically developed, linked with the clinical needs. To do exercises, it is, for example, good thing to be able to start a timer. So we control through this platform all of the chain of visual conference. We have, for example, still in link with clinical leads, the clinicians which bring these projects on. They wanted to be able to do the follow-up of a connected active desk for those who have recommendations to work for a certain time and raise up in other time intervals and do this follow-up. We interfaced watches, Apple Watches, which take data on the people's activities, and we are capable with the Terra platform to get this data in a synchronous manner and do the follow-up adequately. We take this also for use this for our robots that we showed. We have an interface which allows navigation, as we have seen in the other platform, and they dedicated through OpenTerra. So what you have to understand is that we control all of the chain. It is free of rights, and if you have needs on that level, we are eager to hear about them and work with you. The last video is that we are working also to make companion robots, which will be able to interact through speech, by image, and by movement. So that is a robot which is called the T-top for tabletop. It is the equivalent of a tactile pad with camera and microphone on a rotating base, and with a capacity to move a tactile screen to do head signs. We've integrated all of the functionalities that there were on robots that were presented earlier. So this robot, with its head movement, is capable to digitize its own environment and find itself, know where he is in the home, for example, and capable of recognizing objects of the person, faces, voice, speech. So we'll show other examples, clips for this. And the idea is that with robots such as this one, we are capable of observing and characterize the scene from the standpoint of the robot in a richer fashion than what we could do, for example, with an intelligent speaker, which is just recognizing speech and the direction of speech. Now we are able to recognize individuals, associate activities, recognize some people, the things that people do, interact on speech, and generate voice. One of the projects right now, which will start thanks to IVADO and the foundation, is to do a robot which will be able to converse with people. In long-term healthcare, we have to counteract a social isolation. So we are capable of doing just about anything with this robot, and we are aiming to make natural and interesting interactions. And for this, it will require us to develop intelligence of the machine so that the interactions be rich, significant. We see here that we are capable of putting an interface such as an avatar. It can be other things such as images taken in the photo album of a person, which, for example, which suffers from Alzheimer's disease, to remind him or her different places, people from the past, and we'll be able to detect patterns and interactions and react in relation to that. So all of this is developments which are oriented uh, towards making intelligent robots. At the same time, taking an intelligent robot is like tackling an ultimate case of rehab, in the sense that a machine, we must show a robot how to see, how to hear, how to speak, how to move, and how to make sense of these interactions with its environment. So by doing this, we are all can also transfer technologies we are making for persons which have the same deficits and which could be use the technology. So it's the end of my presentation. I hope that you were able to understand the link between numeric health and robotics. Thank you.
Merci vraiment beaucoup pour cette belle
Thank you
présentation
very
sur le
much for
robot
this
et
nice
j'avais justement
presentation, which
commencé
was
mon
really
sujet.
interesting,
Donc nous avons
Mr.
maintenant
Michaud.
5 minutes
So we
pour
now
des
have a
questions
few
du
minutes
public. Et
to
en
and take
commençant,
questions
je
from
vous
the
invite
public.
à
Once
écrire
again, I invite you to
brièvement
write on the
selon
bottom
votre
of the
question,
dialogue
vos questions
if
et il me
you
fera
have
plaisir
questions,
de
and
les
it will be a
relayer
pleasure
à
for
notre
me to
conférencier.
relay them
Donc
to
c'est
our
très intéressant
presenters.
en fait de
So
connaître les
it is
dernières
very
avancées en
interesting to
robotique
see
et
the
en ce qui
last
concerne
advancement in
contribuer
robotics and
pour aider
the
les
practical
participants à
applications
cette unité. Moi, je
for
trouvais
the
que
different
j'avais des
sectors of
aspirations un
society.
peu
I thought
de
that it would
robot compagnon
looked alike,
de
more like
science-fiction. Donc,
these
c'est vraiment
sci-fi
motivant de voir
companion
ça.
robots. It's
Donc, je
really
vais
motivating
commencer avec une
to see
première
that.
question qui est
I
une
would
question
start with a first
générale.
question, which is maybe
Quels sont
more
les
general.
avantages et les
What are the
inconvénients de
advantages and
l'approche
disadvantages of
multidisciplinaire
the
pour un problème?
multidisciplinary approach to a problem? The advantages are, me as a robotician, I can only imagine needs on the side of, if we take on the side of health or assistance care. It's the same thing in other disciplines. We develop on this on robotic science. We push the limits of what the robots are able to do, and we say, well, it could be used to this thing, and we start working on the application, which maybe doesn't have a real need, confirmed with the clientele. So the multidisciplinary approach, as such, doing a robot is multidisciplinary. It's computer and mechanical engineering and integrating all that, but its application is also a domain of expertise. So in the domain of health, we've developed robots for autistic children, for in home health applications, elder care, cognitive care. As robotician, I do not have that expertise, and I do not have that expertise to validate if it is appropriate or not with this clientele. So the multidisciplinary teams in which we are finding ourselves are very complementary, and it's real teamwork, we could say, because I cannot substitute to the clinician, and the clinician cannot substitute to myself. He does not want to do robots, but however, if that machine can help him to process, treat his patients, he'll be happy. So that's the strength of the multidisciplinary approach. And the challenges is the language and the trust, because in a sense that what we don't know, we suppose that it's done quickly. So on the side of users, well, it's like, well, yeah, your robot it should be able to do this. It seems simple as things that we do naturally amongst us. It's more difficult than you think. We are moving ahead. We are very close to what we are seeing in sci-fi, I would say, and it's the same thing on the level of clinical tests. We could say it took us 3 years, for example, to develop the robot, 2 to 3 years, and now clinical tests will take 2, 3 months. No, no, no. It requires more time than that, and there's other challenges on that level. So to understand the reality of each and trust ourselves that it's gonna work out and that we'll be able to get there, it's narrative to do it, and the language, the common language, so that we can understand ourselves. There are issues that could be overcome. We just have to accept to live with a certain level of risk as researchers. We are used to controlling our territories a lot. and now we have to let
Heu
go a bit,
et c'est
and,
beaucoup plus,
but
gratifiant
it's a
quand ça
lot
fonctionne.
more
Puis on aime
gratifying when
vraiment
it
les en
works,
faire. C'est
when
vraiment
we start
outre que
starting to do
faire
transfers.
avancer la science à travers nos articles, les
It's,
conférences et tout
nice
ça,
to
de
have
voir que la
science move,
technologie peut servir
forward, to see
vraiment à
that
aider les gens,
technology can be
c'est
used to help
c'est une
people.
très
It's,
grande richesse.
a very, very
Merci beaucoup pour
interesting
cette
wealth to
réponse
have.
très
Thank
complète.
you
En
very much
fait,
for your answer. It's
je
very
me suis posé
thorough,
dans le
as
cadre
much as on the
de
benefits
mon
than the
recherche
advantages.
et
So we have a
d'études de
question of the public,
comportement
which
de
comes from
l'organisation
Adina
dans un
Bin
contexte
Khalifa.
numérique qui
In
évolue
the
tout le temps. Qu'est-il
multidisciplinary
développe
context,
un
can we
nouveau
speak
rôle
about a new
d'intégrateur en IA?
role, integrating role in
Ben,
IA?
je pense que
AI.
oui,
I
tu
think
sais,
that
en
yes.
soi, la partie
As
intégration, là, en
such, the
robotique,
integration
c'est
part
un
in
défi
robotics
majeur.
is the major
Bon,
challenge.
nos laboratoires de recherche en robotique, la
Our
plupart sont
research
orientés
labs,
sur
most are
l'aspect, on va
oriented
dire,
towards the aspect, I would say, of
la
specific
perception, le
aspects with the
raisonnement, l'action.
perception, reasoning, action,
L'intégration, tu as un robot,
and
c'est
integration of a
plein de morceaux
robot
qu'on doit mettre ensemble.
is many
Seulement
pieces that
qu'une
we
fois qu'ils
must
sont mis
put
ensemble
together.
qu'on peut vraiment
It's
voir
only
tous
once
les
they're put
effets.
together that we
C'est
can
la
really
même
see the
chose au
benefits.
niveau
And it's the same
application.
thing on the
Donc,
level of
du
application.
point de vue clinique et
So, from
thérapeutique,
the clinical
l'intégration
standpoint,
des
the
dispositifs
integration part of
technologiques ou numériques
the
avec la
apparatus
clientèle,
with the
pour
clientele
traiter
and numeric and process
l'acceptabilité,
the
l'adoption, c'est
acceptability
vraiment le fond
take
dans
up
les
is
approches de
essential. And then
user-centered
we're
design.
getting into
Mais
user-centered
ça,
design
c'est
approaches,
pas
which
tant
aren't
d'avoir des
done
clients qui
without having
s'intéressent à cette
people
dimension-là,
which
c'est
are interested,
l'intégration
that
des
dimension
users,
of integrating users,
parties prenantes. Les
of
parties prenantes, on parle des
stakeholders,
cliniciens, puis ceux
and stakeholders, not
les aidants
just
naturels ou les
clinicians
patients, c'est aussi les
and
technologues. Donc,
informal
ça
caregivers,
devient une
it's
spécialité en
technologists, and
soi.
it becomes a
C'est pour ça
specialty
qu'on
as
a mis en
such.
place le programme de génie robotique qui vient
We've
cibler
implemented the
spécifiquement les
robotics
efforts d'intégration
engineering,
qui
which
sont
addresses
propres
these
à cette
integration aspects that are
dimension-là, puis
things that are
ça fait en
specific to
sorte
that
qu'on
dimension,
peut
which are
aller chercher des
essential
breakthroughs, là.
to operate
Donc,
everything.
merci beaucoup pour
Super.
votre
Thank you very
conversation.
much
Encore une
for
fois,
your
ça m'a beaucoup
presentation. And
aidé
once
dans mes
again,
recherches et
it is
j'espère pouvoir
already
revenir
over. It's all the time we
prochainement
had.
pour des
So
questions.
many thanks for the
Je vais vous
questions.
rappeler que vous
And
recevrez un
I would like
questionnaire
to
de
remind you that you
satisfaction
will receive
à
a
cocher
satisfaction
quand vous
survey
allez
by email. So we
répondre.
invite
Et
you
si vous
to
répondez à ce
answer it.
sondage, en
And
plus,
if
vous
you
pourrez
answer to
avoir
this
l'accès à
poll,
l'IVADO pour
you will
notamment
have a
voir les
VIP
conférences
access
du
to
31
review the
septembre.
conferences
Alors
of
maintenant,
the
on
three
a droit à
themes.
une
So
courte pause
now
jusqu'à
we have a short
16h30.
break
Je vous invite à
until
garder des notes
4:30. I
pour la
invite you
conférence de
to remain
closing
with
avec
us
Cynthia
for the
Rodeau du
closing
Institut
presentation
des
with
sciences
Cynthia of the Duke
eHealth
Computer Science
Senior Award
and of the
ou de
AI
Joshua Bengio
School
pour
Award.
un mot
And
d'introduction.
Joshua
En fin
Benjo
de
will do
course,
an introductory
revenez-nous.
word.
Nous
So have a good
reviendrons
break.
ensemble à
Come back with
16h30
us
et à la fin de
at
l'événement, mes
4:30
commentaires.
and have a good event.
Merci
Thanks
beaucoup.
again. Thank you very much.